Hello, students. This is Ms. Dyer with the update from class on Friday. There's not a whole lot that we went through today that is different from yesterday. I basically just went back through the first example where the distance doubles, the one that you can see here on the screen, and we talked about how this occurs. And we did finish up by saying that the force of gravity, our force of gravity in general, is inversely proportional to the square of the distance. Okay, and the way that we came up with that is that if our distance doubles, that's actually squared. Okay, so it ends up being squared. Because our distance is squared. So our force of gravity, our force of gravity is inversely proportional to the square of the distance. Our force of gravity is inversely proportional to the square of the distance. So that's kind of the description of what we're looking at here. One thing that we did go through to make just a little bit clearer is how I can pull out the fraction. So if I write x over 2y squared, that's the same as x over 4y squared. And so if I want to separate this out, I could say 1/4 times x over y squared. And I believe for pretty much all of you, this looks familiar. You're like, oh, sure. Yeah, that makes sense. This is exactly the same thing that we're doing when we have g times m1, m2 over d squared. Let's say we have 4d squared, like we just did. We can pull that out to say 1/4 times g times m1, m2 over d squared. Just like we kind of put in an understood one here, we can also put in an understood one there. And so we can pull that fraction out to the front. And then this value remains. Just like up here, that value remains. So we went through that and we looked at it again with the second value. And so I'll just go through that. So if we have x over 1/4, 1/2 y squared, that would be x over 1/4 y squared, which would be the same as 1 over 1/4 times x over y squared. So the variables here really wouldn't change at all, but you can just pull those numbers out to the front. And so this is the same basic idea of what we're doing in the second example that you worked through. And those two examples were all that we did in class. So if you haven't done your second example, go ahead and do that. And then come back and I'll show you what the answers are. So pause your video now if you haven't done your second example from the PowerPoint. Okay, now that you are back with me, here is the second example. So we have our original distance. Our masses are not changing through any of this because we have the same two objects. One's orbiting the other one, I suppose, and or not. For this purpose, it doesn't really matter. But we have them this distance apart, and then we have them this distance apart. So this is our first distance. This is our second distance. Our second distance is 1/2 of our first distance. So these are like half as close together as those are. So again, when we start out, our original force of gravity was 16 units. So what is our new force of gravity? Okay, and I just used a different number here. Anything to make a distinction between this force of gravity and that force of gravity. So I don't know what the units will be here. So I've got this new force of gravity equals g times 1 m1 m2 over 1/4 d squared, because that's our 1/2 squared and our d squared both. So we got both of those in there. So just like I did above, or I did in the on the back of this page when I showed you what we were doing, I can pull that 1 to the front. I can pull that 1/4 to the front. And so I have 1 from the top, the numerator. I have 1/4 from the denominator. I can make a fraction here, times g times m1 m2 over d squared. Um, Here, I went ahead and did like an old school trick. Instead of doing that, you could say, and I think this is probably easier, you could say 1 over 0.25 times g times m1 m2 over d squared. And then here, um, if you multiply, so I'm going to kind of close that off. If you multiply this out, you'd have 1 over 0.25 times 16. So 1 times 16 is 16. 0.25 over 1, or times 1 is 0.25. So 16 divided by 0.25 will give you 64. So it's 64 units is your new force of gravity. Okay? So 64 units right there. If you if you are dividing by a fraction, you can flip that fraction and multiply. It works the same, or you can invert the fraction. That's the old way of doing it, like back in the day when I was a kid. I think they teach you a different way, and it's just easier if you use 0.25. It's a lot less complex. So in this case, the force of gravity increased by 4 times the original, or it quadrupled. Okay. So what this means and what we can see is that if we have an increase in the distance, we're going to have a decrease in the force of gravity. If we have a decrease in the distance, we're going to have an increase in the force of gravity. So if we have an increase in the distance, we'll have a decrease in the force of gravity. If we have a decrease in the distance, we'll have an increase in the force of gravity. What that matters for us, and we'll talk about this when we come back. We've got our planet here versus our planet here, and there's our sun. Here we have a smaller distance, which is going to result in a larger force of gravity, which is going to result in an increased velocity. It's going to go faster. Here we have an increased distance, which is going to give us a decreased force of gravity, which is going to result in a decreased velocity. It's going to go slower. So this is faster. This is slower. We have another step that we'll want to put in after we come back from break, but this will do it for right now. Hope this is helpful. And if you have questions, you can save them up for when we come back, or you can email them to me. Thanks, and have a good day.